8.3 Surface areas of pyramids. I'm going to do a little quick recap of difference between pyramids and prisms before we start, just because I think it's something that's important. I want everybody to write this down so that you know the differences. That way it won't be a surprise when you have a question like that, like we did on the homework quiz. So the main difference, and this is where you should look first, is that a prism has two bases, but we have to remember that they are parallel. Okay, and that means when we have parallel lines, they go in the same direction, they will never end up intersecting. Okay, it'll never happen. So they have to be parallel. And a pyramid only has one base. So these two are not really in the book or anything, but the top on a prism comes to a peak where the top comes to a point on a pyramid. So in other words, if I have a triangular prism, okay, and you don't have to write this, you've already done this a bunch of times, but if it looks like this, here's where my peak comes. So it comes up to here, and on this side it would come up to here on a peak. On a pyramid, it starts with a point down here, so let's say I had a rectangular pyramid, okay, and I connected them this way. I've only got one base, which happens to be this spot right here. My base over on this side is this triangle and this triangle, because they're parallel. This only has the one base, and then it comes to my point. My vertex is up there and a point. I have a vertex up here and a vertex up here because there's 2 points on a prism that they meet at to continue an edge, which would be right here. There is no edge up there, is there? So that's where you have to know the difference. How do I name a prism and a pyramid? Well, we name it according to the base on both of them. So this one in particular, I know this is getting sloppy, but this base this prism happens to be a triangular prism only because, oh, I didn't know I was going to erase the whole thing. Only because if these two are my, if this is one base and it's a triangle and I have a parallel one, meaning they're never going to intersect, that's what my base is. So it is a triangular prism. Sorry, that is really bad handwriting. This one over here, my base happens to be a square or a rectangle. We'll say a rectangle because we're not 100% sure. So that becomes a rectangular pyramid. I hope that helped a little bit. Let's move on to surface areas of pyramids. So our first key idea is the net of a square pyramid. Well, first of all, we just learned how do we decipher whether it's, what it looks like. If I had a square pyramid, okay, I'm going to start off with a base that is a square. Now I'm just doing mine a little bit differently because I'm trying to get my points to look like they should. There we go. So that one in the back is the only one that wouldn't really be showing. So basically I've got my square right here that becomes my base, and then I use my vertex up at the top, which is right here, to connect all of the edges. Okay? If I were to unfold this, I literally end up with the bottom being my base, which we know is a square. Okay? And then if I just had all of these drop out, there's 4 of them, there's 4 faces, they would just fall out just like this. And that's what it would look like flat. And this would be a bottom, a side, a side, a side, and a side. If I were to fold them up, same thing. Alright, example 1 is finding the surface area of a square pyramid, and I've already got mine drawn out here for you. So what I've got here is, we know it's a square pyramid, so that means my base has to be a square. When I start my vertices, I just go straight down and I make it a pyramid shape. One thing you'll notice is because this is a triangle, they show us where the height is with that little square, which means it's a 90-degree angle. So my length of this is 7. If I know it's a square, then I know that this length is also 7. Sorry about that. I know that's also 7. So I know that's also 7 over here. And that one too. So they're all 7. I don't have to keep writing them out. Then I know my height is 10 meters. Now, if I'm going to try to find the surface area of this entire square pyramid, there's a few things I need to know. Well, first of all, I can flatten this out. Pyramids are much easier to flatten out because I've got my square. This is an equilateral triangle because there's a right angle down it, from what we can tell. And it would just fall into place like this. Very similar. So this is my bottom. These are my sides. And what I would have to kind of know here is that I've got this spot right here that's proving that it's 10 meters. And then I know that my bottoms, or my square around it, those are all 7 meters. These are my sides over here, and that's my base in the middle of my bottom. Okay, so now I've got 4 different sides to deal with, and I've got 1 bottom. So remember how we wrote these over on the side just like we did before. And then I have side. Now I have 4 of them. So I'm just going to show you it like this. I'm going to write out 4 of them. And they're all going to be very similar, obviously, because they're the same. So let's start with our bottom. So if this is, I'm figuring out what is the formula for a square. Well, it's side squared, right? Side squared is going to equal 7 times 7, which equals 49. So that's my bottom. That's my square. My the area of my bottom is 49 square feet. I'm sorry, meters. We're talking about meters. Then my side is a triangle. So I have 1/2 times my base times my height, which equals 1/2 times my base, which right here is 7, times my height, which is 10. So I can just do, it'd be easier just to do 7 times 10 is 70, divided by half, or times half, or divided by 2, is 35. Now, do I have to keep doing all that work for the other 3? They're identical. Everything's the same, or they would have given us different measurements. So you need to show your work this way, but you don't have to do the math again. Okay? So I just copied all those in there for that reason. Now, I can't really do my equal sign underneath, so I've got 49 plus 35, and I could just multiply that by the 4 sides that I have, but I could also just write it like this because that's how I have it written out anyway. And I should come up with a total area of 189 meters squared for my final answer. That's the surface area of this square pyramid. So number 1 is identifying what is a square pyramid. Second thing is unfolding it. What does it look like? How can I get those edges and get all this information in there? Okay. So your answer is 189 meters squared. And the next key idea is the net of a triangular pyramid. So a little bit different. If I have a base that is a triangle, and then I connect all of my vertices. Actually, I'm going to erase these little marks because that would be the background, right? And then I connect my vertices like this. I'm not going to have any background one. But I notice that this is a triangular pyramid because my base is a triangle. And then my vertices go straight down, right? So now I want to unfold this. To unfold it, I just have to look at what my bottom is. My bottom is just a triangle that looks like this. Okay. And then my sides, if they were just to kind of scoop down, they would all just fall like this. So these are my sides, and this is my bottom. That's how you would unfold them. So much easier than trying to unfold a rectangular prism or rectangular or a triangular prism or something like that. It's a lot easier to do it this way with the pyramids. Example 2 is finding the surface area of a triangular pyramid. So again, we're going to start with a triangle, and we're going to flatten it out, find the bottom and the sides, and get the area of all the faces to find the total surface area. Before I put the other measurements in this triangular pyramid, I want you to watch because it's kind of hard to visualize where the heights would be. So the height of this triangle would go straight down here, and this would be your right angle. And that height would be 5.2 feet, according to this problem. And then the other height that we have to see is from either, we can do this triangle here, or we can do this triangle here. Okay, so you've got to really kind of be careful how you're labeling. I'm actually going to fix this and put it on the other side, so if you put it there, just so that you can see it. Like I said, it's hard to, this is going to be the hardest part of actually doing the surface area on something like this. So then you have to visualize this line coming down right here, and this being a right angle, and that measurement being 8 feet. Okay, so I know it looks a little funky, but that's how it has to be. You know, you have to look at, every triangle has to have a right angle on it, right, to find the height. So if you don't have a height for a triangle, then you can't find the area of something. So you just got to remember that. Find the height, find what you can plug into your formula, and it should work just fine. So let's look at this if we were to put it as a net. So this is what you would be seeing, and this height is going to be your 8 feet because it's the one that's on the side. The one that's on the base will be right here. It will be the 5 2/10 feet, or 5.2 feet. And then your side, I'm sorry, your base of your triangle right here is going to be the 6 feet that they showed here. Okay, so we have all of our established measurements. Now we just need to put them into what pieces will we have. Well, we have a bottom, and then how many sides should we have if we're talking about a pyramid with a triangular base? Should have 3. So we have side, side, side. I put in all of the formulas because you have to remember it's a triangular pyramid. So all of them will be 1/2 times base times height. So plugging in those numbers, I'm going to start with my bottom. I have it would be 1/2 times my base, which is my 6 feet, times my height on this one, which is 5.2 feet. Then my second one down here, one of my sides. Now these sides are all the same, or they would have given us different measurements. My base right here, let me get my orange out again. So my base right here is the same. It's 6 feet. So I've got 1/2 times 6, times 6. And then my height of this triangle right here is 8. And then those will all be the same. Okay, so I'm just going to do the math out for you real quick. If you took 1/2 and multiplied it by 6, you'd have 3. 3 times 5.2 ends up being 15.6. And then if you were to take, you could either take 6 times 8 first, or you could take 1/2 times 6, which is 3. 3 times 8 is 24. So that means all of these will equal 24. And then you just simply add them all up. So I have 15.6 plus 24 plus 24 plus 24. And again, you're all going to have different ways of evaluating it and getting the final answer. But your answer should be 87.6 feet squared. I'm not going to have any tryouts on this one. We will do some practices in class. So you're all finished with the video today.